Hello and welcome to this uh, podcast. And I'm going to solve yet another problem of number theory from Putnam. So this was asked. This is in fact B3 from 2018. It says that you have to find all positive integers n less than 10 to the power 100, which simultaneously divide such that n divides n minus 2 to the power n minus 1 divides 2 to the power n minus 1, and n minus 2 divides 2 to the power n minus 2. Right, so what I'm going to do is that, simple. What's simple that, first of all, I'm going to claim that, uh, what I'm going to claim is that e to the power m minus 1 divides e to the power n minus 1 if and only if m divides n. This is true, and you can sort of prove it. So I'm just quickly going to prove it. Say that if m divides n, so which means that you will say that for some integer I, n is going to be equal to n times I, right? So e to the power n minus 1 will be equal to e to the power mi minus 1, okay? And that can be thought of as that this is e to the power m to the power I minus 1 to the power I. And this can be further written as e to the power m minus 1 into e to the power I minus 1 into m, and so on. So you can see that e to the power n minus 1, in fact, e to the power n minus 1 is divisible by e to the power m minus 1, right? So that's the forward thing. The backward thing is that if this is true, then we'd like to believe that, m divides n, and that's not too difficult to prove. Uh, so if this divides that, so it means that all the roots of e to the power m minus 1 equal to 0 are contained in the roots of e to the power n minus 1 equal to 0, right? So because you're saying that this number divides that number, so it means that all the roots of this must be contained in this. So typically, what does that mean is that a root of this form, so typically a root of this equation will look like e to the power I to k pi by m. And typically a root of this equation would look like e to the power I to k dash pi by n, right? And well, so since all the roots of this equation are the roots of this equation, that means that for some m and n, these numbers are going to be same. And since they're of moduli, unit moduli, so we can agree that their arguments must differ by 2 pi or some integral multiple of 2 pi. So this is going to be true if and only if 2k pi upon m minus 2k dash pi upon n is equal to some integral multiple of 2 pi, because their arguments are equal. And might I add that k must lie between, say, 0 to, k can take all the values between 0 to m minus 1, right? And for all values of k, this must be true. Now, if you were to simplify this, you can cancel 2 pi and you can multiply by mn. So we'll get is that, rather you'll get kn minus mk dash is equal to lmn. This is what you'll get, right? So that's essentially what you get, right? Is that okay? Now, have a look at this. So this is divisible by m, this is divisible by m, so this must be divisible by m, okay? And there is a problem that this can't be divisible by n, right? You have to extend this further and you'll get why it's not divisible by n. So that's that's the thing that it must not, because there will be some prime. You can think of it is that this way, that if m divides n, so there will be some prime in P that's not in n, because we are saying that, say that this number divides this number and still m doesn't divide n. So which means that there's some prime P which still doesn't divide n, which is not there in n, right? Or if at all, or because n has to be greater than n anyway. So you can argue that this number will be divisible by that prime. This will be divisible by that prime. This wouldn't be divisible by that prime, because k, if you were to pick the value of k which is less than that prime, so this is not going to work, right? So a contradiction, which means that m should divide n. Right, so now that we have established this part, that a to the power m minus 1 divides a to the power n minus 1, if and only if m divides n. Let's get back to the problem. The problem says that, first condition says that n divides 2 to the power n, right? So n divides 2 to the power n essentially tells you that n must be of the form of 2 to the power a. Any divisor of the form of the number 2 to the power a must be 2 to the power n must be of the form of 2 to the power a, right? Now the second question says that n minus 1, which is 2 to the power a minus 1, must divide 2 to the power n minus 1. And 2 to the power n minus 1 would mean n is now 2 to the power a, this minus 1, right? So now you can see that a to the power k minus 1 or a to the power m minus 1 divides a to the power n minus 1. That means that a divides 2 to the power a. So we get back the same equation. So if a divides 2 to the power a, it means that a must be the form of 2 to the power b. So which means that n must be of the form 2 to the power b. Right, so the third condition says that n minus 2, which means that 2 to the power b minus 2 divides 2 to the power n minus 2. What's n? N is 2 to the power b minus 2. So n minus 2 divides 2 to the power n minus 2. So if you divide it by 2, you'll get that 2 to the power b minus 1 divides 2 to the power 2 to the power 2 to the power b minus 1, right? So again, a to the power m minus 1 divides a to the power n minus 1. It means that m divides n, which means that 2 to the power b minus 1 must divide 2 to the power b minus 1. And again, so a to the power m minus 1 divides a to the power n minus 1. That's only possible when b divides 2 to the power of b, which means that b must be of the form of some number like 2 to the power c. So I think we have got n. N is fundamentally of the form of 2 to the power 2 to the power 2 to the power c. And we need all numbers which are less than 10 to the power 100. So we begin by setting c equal to 0. So if we were to set c equal to 0, we'll get, so there's 0, so there's 1, so there's 2 to the 2, which is 4. 4 is definitely less than 10 to the power 10. How about if we were to put c as 1? So if you were to put c as 1, you'll get this as 2, so this is 2 to the power 4, right? Something like that. What if you were to put c as 2? So if you were to put c as 2, so this is 4. So this is 2 to the power 16. And 2 to the power 16 is definitely less than 10 to the power 100, right? How about if you were to put c as 3? So if you were to put c as 3, you'll get this 3. So this is 8. So this is 2 to the power 8. 2 to the power 8 is, well, 2 to the power 256. And 2 to the power 256 is still less than 10 to the power 10. Why? Because 2 to the power 256 can be thought of as 2 to the 3 and to the it's 1 and so 2 to the power so 2 to the power 256. In fact, you can think of this way that 2 to the power 256, in fact, is less than 2 to the power 258. Definitely that's true. And that's equal to, in fact, 2 to the power 3 to the power 8, 86. And which is equal to 8 to the power 86. And 8 to the power 86 is definitely less than 10 to the power 100. So this works. Right. Then we will try c equal to 4. So if you were to try c equal to 4, you'll get 2 to the power 4, which is 16. So you'll get 2 to the 2 to the 16. 2 to the 2 to the 16. Now my claim is that this number is greater than, in fact, 10 to the power 100. And you can figure out why. Uh, it shouldn't be difficult to see that why this must be true. Uh, you can say something really nice and trivial, in fact. Argue that you can take 2 to the power 4 and pull it aside. So what you'll get is 2 to the power 2 to the power 16 is, in fact, you can say that there is 2 to the power 4 and times 2 to the power 16 minus 4. And that's in fact greater than 10 to the power 100. And that's easy to show because, well, you can think of this as that this is, or rather, I haven't done this well. So it was 2 to the power 2 to the power 16. And what I'm going to do is that I'm going to compare it to 10 to the power 100. So all I need to do is that I need to check a base which is close to 10. So how about 2 to the power 4, right? Think about 2 to the power 4. 2 to the power 4 is just find a base, right? Are you getting my point? And because that's 16. So 16 will be greater than 10. And the remaining exponent, if that comes out to you as greater than 100, so we are done. And which comes out to you as greater than 100, so we are done. So that will be 8. So there are only 4 values which work, right? Okay.